Determine the hexadecimal equivalent of the following number systems. We have Roman 1. We have this number which is in base 2, and we have the other number which is in base 10. And we are supposed to convert to hexadecimal number. So, number systems, we have binary numbers. These are base 2 numbers. We have decimal numbers. Decimal numbers are also called ordinary numbers, and these are base 10. We have the octal and base 8, and we have the hexadecimal, which is base 16. Another thing I would say is that in base of a number, when we say base 10, base 16, that word base can also be used, the word radix can be used in place of it. So you can say radix 16 or radix 8 instead of base 8 or base 16. So another term we can use for base is radix. So these four base systems, you have to know how you represent them. For example, binary numbers, we know that is zeros and ones. For example, the way we have in Roman 1. In decimal numbers, we normally have 0 to 9. In octal, we normally have 0 to 7, because when you count from 0 to 7, those are 8 representations. And in 16, we have 0 to 15. And very important, in hexadecimal, when you are writing the binaries, when you are writing to the equivalent binaries, or else I would want to say that in hexadecimal, we normally represent from 0 to 9, and when we reach 10, we start with A, then we follow with B, C, D, E, F, instead of writing 10. But in the real sense, we normally know, we usually know that A represents 10, but we don't write the 10, we write A, then B up to 15, which is F. That is for hexadecimal number. And the other thing is that when you are encoding octal numbers, when you are writing octal numbers in binary, it is a must that every digit you write in 3 bits. So you encode in 3 bits. And in hexadecimal, when you are encoding into binary numbers, it is a must that you use 4 bits. That is for each digit. You must represent each digit using 4 bits. For the decimal, we don't have any rule when we are writing in binary equivalent. So let's do our question. We have Roman 1, which is 1 0 0. We have 1 1 1 1. We have 1 1 1 1. Then we have 0 1, and we have 3 zeros. So this is a binary number, and we have to convert to hexadecimal. And I have said in X, we normally use 4 bits to represent each digit. So in that case, when given binary number, you have to group the binaries from right to the left, using 4 bits, groups of 4 bits. And in case it happens that the last group has no 4 bits, you add zeros to the left to make 4 bits. So let's do that. So in this case, we shall have our first group there. We shall have from here up to there, from this point up to that point, and then the last group we have that group. So all the we have all the groups having 4 bits, so we are not adding any bits to the left. So after doing that, you write the hexadecimal number representation of each group. So when you consider, for example, the first group, which is 1001, you find that when you look at the when you convert this, you'll get 9. When you look at these 4 ones, you'll find that it is 15. And I have said, when you convert 15 to binary, you'll find that it is, you get 4 ones. But in hexadecimal, we write F. Next, you'll get E. And the other one is 8. So in this case now, our hexadecimal number is 9F E8 by 16. Then Roman 2, we have this number. It is not 0.66. We have a 0 here, so it is 0.06 640, then 625. So we have a 0 after the decimal point. So this is base 10, and we have to convert to base 16. So when you get a decimal point number which is in base 10, and you want to convert it to any other base, be it base 2 or 8 or 16 that we are doing right now, you multiply repeatedly by that particular base that you are converting to. So in this case, this decimal point number is in base 10, and we are converting to base 16. So we are going to multiply throughout by 16, repeatedly by 16. And this is how we do it. Our number is 0.06 0.06. Let me write it. We have 0.06 640, then 625. So we have our number there. So we shall be multiplying by 16 the decimal part. The decimal part is the one that is multiplied by 16. So let's have our product here. Then we have our x digit that will be extracting from the product, our x digit. So this is how we do it. You multiply this. When you multiply this, you get 1.0625. So the one that goes to be multiplied in the next step is the decimal part. So you take the whole part of the number to now be to represent now the x digit that we will extract from that. We take the decimal part, we multiply again by 16. In this case, we'll get 1.000. We extract the x digit from the whole part, which is 1. And as you can see now, we have got 3 zeros. And these 3 zeros we cannot multiply because we shall be getting zeros all through. So in this case, that is our last step. So after that, in this case, when you are multiplying, you read from top to bottom. So in this case, our number which is in hexadecimal will be in 0.11, and this is in base 16. The reason why I'm saying from top is because If we add a number like 64 base 10 and we are told to convert to base 16, we could divide this 64 by 16, and whatever remainders we get in this part, we have to write them from bottom to top. So when we are multiplying the decimal part, the direction changes. So that is the answer for that question.